In today's interconnected software systems, especially microservices architectures, failures are inevitable. A single failing component can cascade, bringing down an entire application. This is where the circuit breaker design pattern comes in, acting as a crucial mechanism for building resilient and fault-tolerant systems. Inspired by electrical circuit breakers, this pattern prevents an application from repeatedly trying to execute an operation that's likely to fail. Instead of continuously retrying a faulty service, which can overload it and worsen the problem, the circuit breaker trips and redirects traffic away from the failing component, allowing it to recover. The circuit breaker pattern operates in three main states. The first is the closed state. In this normal operating mode, requests are allowed to pass through to the protected service. If a call fails, the circuit breaker records the failure. If the number of failures exceeds a predefined threshold within a certain time frame, the circuit transitions to the open state. When the circuit breaker is in the open state, it immediately blocks all requests to the failing service. Instead of attempting the call, it returns an error or a fallback response to the client. This gives the failing service time to recover and prevents further resource consumption and potential overload. After a configurable timeout period, the circuit automatically transitions to the half-open state. In the half-open state, the circuit breaker allows a limited number of test requests to pass through to the previously failing service. If these test requests succeed, it indicates the service has recovered, and the circuit resets to the closed state. However, if these test requests fail, the circuit immediately returns to the open state, extending the recovery period. The circuit breaker pattern offers several key benefits. It improves system resilience by preventing cascading failures, enhances fault tolerance by gracefully handling outages, and provides faster failure detection and recovery. It also helps preserve system resources by avoiding unnecessary calls to unhealthy services, leading to a more stable and reliable application. By implementing the circuit breaker pattern, developers can build more robust and self-healing distributed systems, ensuring a better user experience even when underlying services encounter issues. It's a fun